Today I will be discussing the Zener diode and its use as a voltage regulator. This presentation covers the fundamental principles, key characteristics and some practical applications of the Zener diode in electronic circuits. Let's begin with a brief overview. The Zener diode resembles a regular diode but with a bent cathode bar, indicating its special breakdown characteristic. A Zener diode is a heavily doped, specially designed PN junction diode that operates in the reverse breakdown region without any damage. That is the specialty of the Zener diode. It maintains a nearly a constant voltage across it, whether irrespective of the changes in the input voltage. This is the specialty. Let us see the VA characteristics of the Zener diode. When forward biased, it behaves like just a PN junction diode allowing current flow. However, when in reverse biased, it exhibits a sharp breakdown at a certain voltage known as the Zener voltage or VZ. Beyond this breakdown region, the current increases significantly while the voltage across the diode remains almost constant. This property makes it ideal, and for voltage regulation it is very suitable. Here we can see the VI characteristics of the Zener diode. Let's see the differences between Zener diode and the avalanche breakdown. There are two types of breakdowns, Zener and avalanche breakdowns. Zener breakdown occurs at low voltages, typically below 5 volts, due to quantum tunneling caused by a strong electric field in heavy doped diode with a thin depletion region. It has a negative temperature coefficient. It means breakdown voltage decreases slightly as temperature rises. Avalanche breakdown, on the other hand, happens at higher voltages above 8 volts, caused by impact ionization, where carriers gain energy and create new ones through collisions. This occurs in lightly doped diodes with thicker depletion regions and has a positive temperature coefficient. Despite these different mechanisms, both allow diode to maintain constant voltage during breakdown. Here we can see the VA characteristics of the both Zener and avalanche breakdowns. Zener diode is very sharp cut at the breakdown, while the avalanche breakdown has a less sharp cut. Now we see the how we can use Zener diode as a voltage regulator. The simplest practical use of Zener diode, it is the voltage regulator. It consists of a series resistor connected to the input voltage source and the Zener diode connected in reverse bias parallel to the load. The resistor limits the current flowing into the diode and the load. When the input voltage exceeds Zener voltage, the Zener diode conducts in reverse breakdown, maintaining a stable voltage across the diode. If the load current changes, the diode adjusts its current flow to keep the output voltage constant. We can see the operation here. When V in is less than Vz, Zener diode conducts in breakdown region and clamps output voltage V out is equal to Vz. Load current change is absorbed by Zener current so that V out stays almost constant. When V in is greater than Vz, Zener is off, output follows input. The key formula governing the circuit volt is equal to V out is equal to Vz, meaning the output voltage across load is always steady at the Zener voltage. For proper regulation, the input voltage must exceed the sum of the Zener voltage plus output voltage drop across the series resistor based on the Zener current. Now we can see the applications and advantages of the Zener diode. Zener diode finds several important applications in electronics. Firstly, it is used to provide a regular DC voltage supply, ensuring sensitive electronic devices receive a stable voltage despite of variations in input. Secondly, it offers over voltage protection by clamping unexpected voltage spikes to save levels, protecting downstream components. It is also used as a voltage reference in measurement circuits to provide stable benchmark voltage. Finally, Zener diodes are employed in waveform clipping circuits to shape the signals or suppress the signals noise. Coming to advantages, it is simple, cheap, and fixed, means no moving parts are there in this diode, so it is very steady to use. Also gives quick response to the input changes. So coming to the summary, we learned the following. Zener diode as a voltage regulator works in the way like output voltage equals Zener voltage. Independent of the input voltage variations within limits, the output variation doesn't change. Independent of input voltage variations, independent of load current variations, the Zener diode output does not changes. This is the specialty of the Zener diode. It is widely used for regulated DC supplies and over voltage protection. Thank you.